All right, so today we're going to talk about multiplying and dividing using scientific notation. So if you do not already have these guided notes, they are on Schoology. You can print them and follow along. Or if you don't have a printer, you can just pause and fill this out as we go. So it tells us to multiply values in scientific notation. We're going to rearrange the multiplication problem and apply our law of exponents. So if you look, I lined them up. And this is how I like to do it. If you look, they had two lines and they wanted you to say this times this and this times this. But I line them up and I draw boxes so I can see the parts that I'm multiplying. So I'm going to multiply my decimals and I'm going to multiply my tens. So I'm going to multiply 5 times 2 like I normally would. So 2 times 5 is 10. Turn my pen on. 2 times 5 is 10. Carry the 1. 2 times 4 is 8, plus the 1 we carried is 9, so 9.0. Bring down our times sign, and then we know when we're multiplying like bases with different exponents, we keep the base and add the exponent. So you're going to say times 10 to the 5 plus 3 is 8. So we're left with 9.0 times 10 to the 8th. All right, so therefore that's our final answer. To divide, you're doing the same thing. It says line them up. It tells you to put 2 individual parentheses. I like to line them up and box them. I think it's a lot easier. So I've lined up my division. 8 times 10 to the 6th divided by 4 times 10 to the 3rd. We're dividing 8 divided by 4 is 2. Bring down our times. Again, our division exponent law says when I have matching bases with different exponents, we're going to keep that matching base of 10 and subtract. Top minus bottom, 6 minus 3 leaves us with 3. All right, so I'm going to go ahead and I'm going to do 1 and 3, and then I'm going to let you pause and do 2 and 4. So again, first step, I'm going to line up our scientific notation. So 3 times 10 to the 4 over 7.2 times 10 squared. So we're going to box up our tens, and we're going to box up our decimals. We know when we are multiplying like bases, different exponents, we keep that matching 10, and 4 plus 2 is 6. We're going to bring down our times, and then we're going to say 7.2 times 3. Well, 3 times 2 is 6. 3 times 7 is 21. I start off with 1 behind the decimal, so I end with 1 behind the decimal. And I'm going to take this time to point out that now I have 2 numbers in front of my decimal. We learned on Monday, and then again yesterday when we got answers that had more than 1 behind the decimal, that our standard scientific form is that we only have 1 in front of the decimal. So I need to move that decimal 1 to the left, and we know, and we learned yesterday, that if I move the decimal to the left 1, however many times I move the decimal to the left, I have to increase that exponent by that many. So I have 2.16 times 10 to the 6 plus 1 is just 10 to the 7. All right, I'm going to go ahead and do 3 for you, except for I'm going to put it in standard form first. So I have 2, 1, 6, and I have a positive 7. Do I need to move it to the left or to the right? That's right, I need to move it to the right because positive 7 is greater than 1, and so my standard form has to be greater than 1. And if I move it to the left, it'll be a very teeny tiny decimal that is a lot smaller than 1. So I'm going to move it 1, 2, 3, 4, 5, 6, 7. So 5 zeros, 1 0 for every digit that I didn't have a number for. So 21,600,000. All right, and then I'm going to do 3 for you. Again, they've already lined it up for us, so all we should have to do is box those up and divide. 9 divided by 3 is 3. You're going to bring down your times. 10, when we're dividing like bases with different exponents, keep that matching base. Subtract your exponents. 9 minus 7 is 2. So we're left with 3 times 10 to the 2, and then it wants us to put it in standard form, positive 2 greater than 1. So we need to move it to the right 2 so that our answer, our standard form, 1, 2 is greater than 1. If I moved it to the left, I would have 3,000, which is smaller than 1. All right, I want you to pause this now. I want you to do 2 and 4. Give me that answer in scientific form and standard form. And then when you're done, you can go ahead and unpause this. And in just a second, I'll get started because that means you've had plenty of time to pause this and work through the material. All right, so I'm assuming if you've already paused this, worked it out. If not, while I'm writing it now, you can go ahead and pause this so that you can make sure you know what you're doing before I work through it. All right. So we've already paused it. We're working through it. So I have my two numbers. I've lined them up, and I boxed up the parts that I'm going to multiply. I've brought down my times. We know when we're multiplying like bases with different exponents, we keep that base at 10, and we're going to add that 5 and that 3, giving us 10 to the 8th. And I'm going to rewrite that because that looks like 108 and not 10 to the 8th. So 10 to the 8th. And then we're going to multiply. 5 times 5 gives me 25. 5 times 1 is 5, plus the 2 we carried is 7. I started with 1 behind the decimal, so I need to end with 1 behind the decimal. Is that what you guys got? All right, so then our last step is to go ahead and take that answer and turn it into standard form. So I have a positive 8. Which direction did you move the decimal? That's right, we need to move it to the right because positive 8 is greater than 1, and we want to make a standard form that is much greater than 1 and not much smaller than it. So 7 and 5, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 zeros for every position that we did not have a number. So we are left with 750 million. Did you get it right? If you didn't, do you see what you did wrong? If you don't, please bring that question to class because I will be sure to answer it and help you with that. All right, so at this point, again, you've already paused this. You've worked through this. So you lined them up. You boxed in your decimals and your tens. You brought down your times and said, keep that base of 10 because we have like bases with different exponents. 7 minus 2 is 5. And then you divided. So 2.1 into 9.45. We learned last year and the year before that when we're dividing decimals, we cannot have a decimal in our divisor. So we need to move that. And so 2 goes into 94 4 times. 2 times 4, it leaves me with 84. 94 minus 84 is 10. Bring down that 5. 2 goes into 105 5 times, which is 105. We moved our decimal. I should have brought it up when I moved it. So we're left with 4.5 times 10 to the 5th. Did you get that? If you didn't get that, do you know what you did wrong? Awesome. So our last step, you needed to take that move, put it in standard form. Which direction did you move your decimal? All right, that's awesome. So 4.5, we're going to move it 5 to the right because positive 5 is greater than 1. So I need to make my standard form greater than 1. So for every number that I didn't, every position that I didn't have a number, we put a 0 in, and we were left with 450,000. All right, so again, I'm going to do 5 and 6, and then I'm going to have you pause it and do 6 and 8. The only difference between these and the ones we just did are that before we multiply and before we divide, we have to go ahead and convert that one of them into scientific notation. So remember, and this will be important because you will see this again, when I turn that into scientific notation, I can only have one non-zero digit in the before the decimal. So I can't put a 0, it has to be 1 because it has to be a number between 1 and 9. So 1.2 times 10 to the, how many positions did I move the decimal? 1, 2, 3, 4 zeros and a 1. So times 10 to the 5, is that number in standard form greater than 1? Nope, it's much, much smaller. So it's going to be a negative 5. All right, so 1.2 times 10 to the negative 5. And I'm going to move that 1.2 times 10 to the negative 5. And we're going to line it up with 6 times 10 to the negative 2. We are multiplying those. So let's box up our tens. Let's box up our decimals. Again, bring down our times with our tens. When we're multiplying, keep the base Add the exponents. You have two negatives. So if I lose $5 and I lose 2 more, I've lost 7 in all. So 10 to the negative 7. And then all we should have to do is multiply our decimals. 6 times 2 is 12. 6 times 1 is 1 plus 6 times 1 is 6 plus the 1 I carried is 7. I started off with 1 behind the decimal, so I need to end with 1 behind the decimal. So 7.2 times 10 to the negative 7. So our last step is to take that from scientific to standard form. I have a negative exponent. Does that mean my standard form is much greater or much smaller than 1? That's right, because it's negative and negative numbers are smaller than 1. It needs to be much, much smaller than 1. So I need to move that decimal 7 positions to the right. So I'm going to put it over here on the right side. Sorry, I said to the right, I meant to the left because I need to make it smaller than 1. 1, 2, 3, 4, 5, 6, 7. So we're going to have 1, 2, 3, 4, 5, 6 zeros for those 6 positions I didn't have numbers at. And then I'm going to go ahead and do 7. Again, same thing. I want 1 non-zero number in front of the decimal. I moved it 1, 2, 3, 4, 5 times. So 3 times 10 to the 5 because. And is that number smaller or greater than 1? It's smaller. That's a negative 5. So I have 6 times 10 to the negative 3 over 3 times 10 to the negative 5. We've lined it up, so we can go ahead, box our decimals, box our tens. We know we're going to bring down times. We're going to keep our matching 10, and we're dividing. I should have put my dividing line in between them and not a line like we're multiplying. We're dividing these numbers, so keep the 10, subtract the exponents. I want to write this out for you. So I have negative 3 minus negative 5, because when I have all those signs, I want you to see what's happening. I keep that negative the same, change subtraction to addition, and flip this sign. So I really have negative 3 plus positive 5. When I have a positive and a negative, we know we subtract and keep the bigger sign. So 5 minus 3 is 2, and positive 5 is bigger. So then we would go ahead and say 6 divided by 3 is 2. So we're left with 2 times 10 to the 2. And I need to scroll down just ever so slightly. So I can say positive 2, is that greater than or less than 1? That's right, it's greater than. So I need to take that 2 and move it 2 places to the right so that my standard form is also greater than 1. If you said to the left and you did it and you looked at it, you'd realize it was less than 1 and you'd be able to fix it. All right, I want you to pause this. I want you to do 6 and 8. And while you are working on that, go ahead, pause this. You're working on it. All right, so now at this point, you should have already gone ahead and done it. If you haven't, pause it now. Do it because I'm going to write them out. And while I'm writing them out, you still have a chance to pause it. So then I have 7.3 times 10 to the negative 1. 2 parentheses next to each other mean they're timesing. I need to make this scientific notation. Again, 1 non-zero digit in front of the decimal. So 4 times 10 to the how many positions? We moved it 1, 2, 3. Is that number greater than or less than 1? It's less than, so it's going to be to the negative 3. So we'll line those up. 7.3 times 10 to the negative 1 over 4 times 10 to the negative 3. We're multiplying all those. We can go ahead and box our decimals, box our tens, bring down our times. We know when we're multiplying like bases with different exponents, we add the exponents and keep the base the same. So times 10 to the negative 1. I spent $1. I spent 3 more. So I've lost 4 to negative 4. And then I'm going to go ahead and multiply my decimals. So 4 times 3 is 12. 4 times 7 is 28. Plus the 1 I carried is 29. And I started off with 1 behind the decimal, so I need to end with 1 behind the decimal. Did you get this? If you didn't get this, do you know why this isn't the answer? If you got this, that's great, but I want to show you there is one more step. We have 2 in front of the decimal. We learned Monday, and we used it again yesterday, that our answer has to only have 1 in front of the decimal because that is standard scientific form. So I learned yesterday, though, that if I move the decimal 1 to the left, I have to increase the exponent. So if you want to put on the side there, decimal to the left increases your exponent, and decimal to the right decreases your exponent. All right, so we can go ahead and say 2.92. We said times 10 to the negative 4. Well, a negative, I owe you $4, but I give you 1 means that I now only owe you 3. And then our last step is to go ahead and make that standard form. So I have negative 3. Is a negative 3 greater than or less than 1? That's right, it's less than, so I need to move it 3 positions to the left so that our standard form is less than 1. Did you get it right? If yes, awesome. If no, do you see what you did wrong? If you don't see what you did wrong, that's a great question to bring to our small group today. All right, so again, I need to take this and make it 1 digit in front of the decimal, 1 non-zero digit. So you would have needed to have already, you made it 9.6. We moved it 1, 2, 3, 4, because there's 4 numbers between our original and our new decimal. 4 positions to the right. So times 10 to the 4 positions. We moved it. Is that greater than or less than 1? That's much less than 1. So 10 to the negative 4. And we're going to line it up with our 1.2 times 10 to the negative 8. We can go ahead and box our decimals. We can go ahead and box our tens if it'll let me. And then we're going to divide. So we're going to bring down our times. We know when we're dividing like bases with different exponents, we're going to subtract, and I'm going to write this out just so we can see it. Negative 4 minus negative 8. So we know when we have this, we need to keep, change, flip. So negative 4 plus positive 8, subtract, keep the bigger sign. 8 minus 4 is 4. Positive 8 is bigger. So then our last step is to go ahead and divide 9.6 by 1.2. So I have 1.2 on the outside. Our top dog always goes in the house. Our divisor cannot have a decimal in the house. And looking at that, I have 96 divided by 12. Well, I know 12 times 8 gives me 96. So I'm done. And I'm left with 8 times 10 to the 4th. So then our last step is to go ahead and turn that into standard form. Well, I have a positive 4, so I know that means that my standard form needs to be much greater than 1. So I need to move that decimal 1, 2, 3, 4 positions to the right. All right, I am going to do 9 with you, and then I'm going to have you pause and do 10. So it tells us a top NBA player can earn about 2.5 times 10 to the $7 each year. If he earns $40,000 per year at his starting job, how many times greater is the salary? Well, we are trying to find the difference. So I can multiply these, but that's not going to give me the answer. So I know that I'm going to have to divide. So I have 2.5 times 10 to the 7. But my original starting salary is not in scientific notation. So I need to turn that into scientific notation. I know I can only have 1 non-zero digit in front of the decimal. And I moved my decimal 1, 2, 3, 4. 4 times. So 4 times 10 to the 7. 4 times 10 to the 4. We're going to line them up and divide. Box up our decimals. Box up our tens. So keep our times. Keep our base. Subtract our exponent. 7 minus 4 is 3. And then we're going to divide 2.5 by 4. So 2.5, since it's our top dog, goes in the house, divided by 4. 4 goes into 25 6 times, which is 24. 25 minus 24 is 1. Bring down a 0. 4 goes into 10 2 times, which is 8. 10 minus 8 is 2. And if I extend my page out to finish this, we bring down 1 more 0. 4 goes into 25 times. And we're done. So we have 0.625. Remember, I said it was important, and I pointed it out. We have to have 1 digit in front of our decimal. That digit cannot be 0. So in order to figure that out, I need to move the decimal 1 to the right. When we move the decimal to the right, we are actually going to decrease our exponent. So 6.25, because we move it to the right, and we're decreasing it by 1. So times 10 to the 2. And then our last step is to go ahead and put that in standard form. It's a positive 2, so I know I need a number greater than 1. So 625, because 1, 2 positions to the right. All right, I want you to go ahead. I want you to pause this. I want you to work out 10. Again, you're going to need to convert those beats or the minutes per year to scientific form, and then figure out what you're doing. So at this point, you paused it and you read it, and you saw that 1 times 10 squared is how many times her heartbeats per minute. And then you converted that minutes in a year to 525. 6 times 10 to the 5, because that number is much greater than 1. And then you multiplied, because per means multiplication. So 10 squared and 10 to the 5th. So we're going to bring down our times, keep that 10, add our exponent, so 7, and anything times 1 is itself, so 5.256. 5.256 times 10 to the 7th. All right, and then our last step is to go ahead and turn that into standard form. Positive 7, so we need to make it larger than 1. So we need to move it 7 positions to the right. So 5, 2, 5, 6, 1, 2, 3, 4, 5, 6, 7. So 4 zeros for those 4 places I didn't have numbers. All right, so let's summarize. Let's go back to what we started with. I can multiply and divide using scientific notation. We know that 1, we need to make sure both are in scientific notation. And once we've done that, we're going to line them up. And after we've lined them up, we can box the 2 decimals and box our tens. And then you would multiply your decimals like regular, bring down your times, and we learned that you multiply like bases, you keep the base and add them, and then the same thing for division. You divide your decimals like you regularly would, bring down your times, and then keep the base and subtract the exponents. So 4, multiply or divide. 5, make sure you only have 1 non-zero in front of decimal. And so that means that if I have 0.125, I need to move that decimal to the right. When my decimal goes to the right, it decreases my exponent. And then when my decimal goes to the left, it increases my exponent. So if I had 12.5 and I move it to the left, I'm going to add to that exponent. All right, so if you were working these out and you didn't see how I got something, you can please bring those questions to class because I'm sure you are not the only one who has those questions. So if you have questions, please come. If you want to do some of these problems together, please come. If you feel like you've got it, go ahead and do the work on Schoology. I'm going to say it again. Wednesday, the 28th, that's next Wednesday. All of your missing assignments are due. So if you haven't already done stuff or you're not happy with your quiz grades, because those quiz grades are 60% of your grade, feel free to go in, make the corrections I put on Schoology, or feel free to go in and do them because you haven't already. You have until next Wednesday to do them. All right, guys, have a great day. Bye.